Next we have combinations. So combinations are a little bit different than permutations. The difference is in a permutation, the order matters, right? In a permutation, the order matters. Where in a combination, the order doesn't matter. So we got to think about like, well, what kind of situations does order matter versus order doesn't matter? And there are certain keywords that help us with this. Like the word arrange, when we're arranging books on a shelf, order is mattering. But when we're just selecting or choosing people, like I'm just choosing 3 people, I'm not putting them in order, that's a combination. Again, arranging or putting anything in order, like first place, second place, third place, that's a permutation. The word choose is always associated with combination. Subset of elements, doesn't look like order matters there, and that's C. And then the guest list of 3 friends, up to you. Do you order your friends or not order your friends? If you put your friends in order, first best friend, second best friend, third best friend, that would be a permutation. If you're just like, hey, you guys are all my friends, combination. I don't have those questions on the test, so that was just like a get used to the idea of order versus no order. Everything here is going to be done on the calculator using this formula. NCR. So NCR, again, N is the total number, and then C or R is the number you're choosing. So the number you're choosing. The total number is always the big number, right? So 10 people, and I'm choosing 3 to make a committee. And you can type this under your calculator under Math Prob, and then you'll see the NCR. And so this is going to turn out to be 120. Which, by the way, I feel like we should now talk about the difference between NPR and NCR and what those formulas are. You don't need to have this memorized or anything, but this is where these numbers are coming from. N factorial over N minus R factorial is NPR's, like, I guess, rule, right? So if we take the 10P3 example, this means there's 10 people and I'm ordering 3 of them. So if I think about that, 10 factorial over 7 factorial, this is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then 7 factorial is 7, 6, 5, 4, 3, 2, 1. Everything cancels. Oops, I forgot the 8. So this would just end up being 10 times 9 times 8, right? Which is what it would be for having 10 people and putting 3 in order. NCR is almost the same formula, n factorial, n minus r factorial, but it has this extra r factorial. And that's basically dividing out the repeats, for lack of a better phrase. So if I had 10C3 and I used my formula 10 factorial, 7 factorial, 3 factorial, well, I already know that 10 factorial over 7 factorial is 1098, and then 3 factorial is 321. 3 goes into 9 3 times, 2 goes into 8 4 times, and then that gives me this 120. So if you have the same numbers, there's always going to be more permutations, right? So like 10P3 was 10 times 9 times 8, 720. 10C3 is only 120. There's always more permutations than combinations. Permutations, you don't have to use the formula. Combinations, you do. And it kind of makes life easier, like 52C5, you just go to your calculator. 52, Math Prob, NCR, 5. How many ways could 5 cards be chosen from 52? Oh, only 2,598,860. What? Yep. Now we've got like 2 things that are being chosen, infielders and outfielders. We have 8 infielders, we're choosing 3. 11 outfielders, we're choosing 4. You could do each of these on the calculator individually, 56, 330, multiply them together, 18,480. Same thing with the next one, boys and girls. 10 boys choosing 2, 10 girls choosing 2. You could even type it in all together, you get 2025. So this is combinations.